Good morning. So today we are going to be learning about balancing chemical equations. So we're going to spend about a whole week on this to really get it mastered because this is probably the hardest thing you'll learn this year. But don't worry, I know you can do it. So we've already started talking a little bit about chemical equations, and we've definitely talked about what a chemical reaction is. Remember, a chemical reaction takes place when elements combine. Elements and compounds and molecules combine to form new substances. We talked about the difference between a physical change and a chemical change. Physical changes do not change the composition of whatever I'm messing with or altering. Chemical changes do. Generally, when a chemical change happens, a chemical reaction is going to happen, and we form a new substance. So, like when I take hydrogen and oxygen and I stick them, bind them, or bond them together, then I've got a new substance. I've got water because I have a new bond being formed. We already learned how to read a chemical equation. We know that our reactants are on the left-hand side of the arrow and our products are on the right-hand side of the arrow. And we also learned that that arrow means yield. Chemical reactions, again, are shown by a chemical equation containing reactants and products. Reactants are like the things before. Products are the end result. For example, it's like baking a cake. If I wanted to make a cake, I'd have to combine some eggs and some flour and some sugar and a bunch of other things. I'd put it in the oven, and then the end product would be a cake. It's not the same thing as what I started out with. Chemistry is a lot like cooking in that sense. My reactants are the things that I combine or alter, and my products, again, are those things that are produced. Reactants, again, a substance present at the beginning of the chemical reaction. That's why it's before the arrow. Product is something that is produced during a chemical reaction. It's at the end of our chemical reaction. That's why it's at the end of our arrow. We already learned about coefficients and subscripts. Coefficients are the big numbers, like right here on my slide, the big 2. My subscripts are the little numbers, and they're below the line. There's a name for the line, but I can't remember it right now. They're right below or beside the letters or the elements. Coefficients and subscripts tell us how many atoms are present in the chemical formula, and they also tell us how many molecules are present. Our coefficients, remember, tell me how many molecules. So I have 2 molecules of H2O. My subscripts tell me how many atoms are in H2O. So I know that I have 2 hydrogens in my H2O, and I have 1 oxygen. If there's no subscript right next to the letter, it's understood that there's just one of those atoms in the molecule. So we know from this chemical formula right here that our water is made up of oxygen bonded to 2 hydrogen. And then the big letter 2, the coefficient, tells us that I have 2 water molecules. The arrow again indicates that there is a reaction taking place between my reactants. Remember, that arrow means yield or to produce, because a chemical reaction produces something new. So here we go. We've got our reactants here on the left side. We've got our products on the right side. Our subscripts are the little numbers right down here. We've got 2 of them. And our coefficients are the bigger ones before it. Again, that pink arrow here means yield. When writing chemical equations, the law of conservation of mass has to be a priority. We haven't talked about this law yet, but we're going to talk in depth about it on Monday. In short, though, the law of conservation of mass states that matter is never created or destroyed. That means when I have a chemical reaction, what's present on the reactant side is going to be present on the product side as well. So if I start off here with 1 atom of zinc and 2 hydrogens and 2 chlorines, I'm going to have 1 atom of zinc on the product side as well as 2 chlorines and 2 hydrogens. This tells us that the total mass of the reactants has to be the same as the total mass of the products. That's why we count the atoms. I'm going to show you how to do that in just a second, and that's how we're going to actually balance chemical equations. So my rules for balancing chemical equations: number 1, you can only add a coefficient in front of the chemical formula. So I couldn't stick my big, large coefficient 2 in between my subscript 2 and my oxygen. It doesn't fit there. It needs to be at the front of my molecules. Rule number 2, you cannot change any subscript, and you cannot add any subscript. So the little 2's or the little 3's or 4's, whatever they are, whatever's present has got to stay. If I that's because if I change the subscript, I'm going to change the molecule, changing what's formed. And number 4, which is actually number 3, you must end up with the same number and kind of atoms on both sides of the equation. When you're finished, that means my products must equal my reactants, because as the law of conservation of mass states, matter is never created or destroyed. That means when there's a chemical reaction taking place, what's present before is going to be present at the end, although we do know a new substance is going to be formed, so they'll be present in a different way. So here's how we actually do that. So here's my original equation. We've got 4, my coefficient, sodiums, Na, plus O2, or oxygen gas, yields or creates 2 Na2s and O's. Na2O. That's all one molecule. So now we're going to get the atoms on both sides. So on this side, I have 4 molecules of sodium because I've got 4 coefficient here. That means there's 4 sodium molecules. And 2 atoms of oxygen, because while I don't have a large coefficient here, I know that the subscript tells me that 2 oxygens are bonded together. So I'm going to create a little chart like this down here. NAs equal 4, oxygens equals 2. Now let's go to the product side. I've got Na2O. This 2 means that there's 2 atoms of sodium for every oxygen present. So I've got 2 sodiums and 1 oxygen, but then this big 2 tells me that I've got 2 of those. So I would have to multiply this 2 by this 2, and I'd get 4. And I'd multiply this understood 1 by 2, and I would get 2. Does that make sense? So my question is this equation balanced? Yes, because the number of sodium atoms here on the left side equals the number of sodium atoms on the right side, and the number of oxygen molecules here equals the number of oxygen molecules here. You have to have equal atoms of sodium and oxygen on both sides. Here's another one. So I've got CO plus H2 yields CH3OH. Let's count the atoms on both sides here. I've got 1 carbon on this side, just one oxygen on this side, and 2 hydrogens because of the little subscript 2 right here. On this side, I've got 1 carbon, 1 oxygen, and 4 hydrogens because 1, 2, 3, 4 hydrogens. So if we look like this, do we have a balanced everything? I got 1 carbon, 1 carbon, 1 oxygen, 2 hydrogen, but 4 hydrogen over here. So this equation is not balanced. I have 2 atoms of hydrogen on the left side and 4 on the right side. So here is my issue right here. Now we're getting into how we actually balance this. So we know this isn't balanced, so now our job is to figure out, okay, how do we balance this? And generally we do that by adding a subscript. So where could I add a subscript that would help? You can see here it's done for you in the example problem. I add a subscript 2. So I have 2 molecules of H2 gas or hydrogen gas. Each molecule of hydrogen gas has 2 hydrogens in it bonded together, but I've got 2 of them, so that means I have 4 total. Again, you do that by multiplying the green 2 by the blue 2, and you get 4. So now I have 4 hydrogens on the left-hand side, and I've got 4 on the right hand. So we're balanced. Now we have all the elements on the same side. Okay, we're going to do this one more. And then if you've got any more in your notes, you're going to do them on your own. Let's see how many we have here. So we're going to do this one, and this should be the last one in your notes. Okay, so we've got H2 or hydrogen gas, plus oxygen gas 2 yields H2O. So let's count. We've got 2 hydrogen on the left side and 2 hydrogen on the right side. And I've got 2 oxygen on the left side, but only 1 oxygen on the right side. So is this balanced? Do all these numbers equal one another? No, we've lost an oxygen atom. So that means that this is not a balanced equation. Now we've got to balance it. So look for the unequal atoms here. The unequal atoms are the oxygen, so we're going to try and make the oxygen atoms equal. We can do this by adding a coefficient. Any idea where we would add a coefficient? We're going to actually have to add 2. So if I added a 2 before my H2O, I would get 2 atoms of oxygen, which balances that out. But now I have 4 atoms of hydrogen, because remember, green 2 times the little blue 2 equals 4. So now I need to make one more coefficient here so that I have 4 hydrogens on the reactant sides. What would I do? Hopefully you told me I would put another 2 right here in front of the H2 gas. Now we are all balanced because we have 4 hydrogen and 2 oxygen on the left side and 4 hydrogen and 2 oxygen on the right side. So this is balanced. Now I have an equal number on both sides. So we're going to be going over this again and again and again for the next couple of days. This is just your first introduction to it. If you have any questions, email me, but we'll be doing more of this tomorrow. Have a good day, or Monday. Have a good day.